Hello everyone, today I'll be talking about slope fields and their geometric interpretation.
Alright, so as you guys might already know, a slope field is a visual way to represent a first order differential equation. That's an equation involving a function y and its first derivative y prime. Instead of solving the equation using formulas like we usually do, a slope field helps us see how the solution behaves. It shows us tiny line segments all over the coordinate plane. Each segment has a slope equal to the value of y prime at a specific point. Essentially, each tiny segment tells us how the solution curve is moving through that point, whether it's increasing, decreasing, or if it's just flat. Now, let's go through an example from the textbook so you guys can understand what I'm trying to say. Alright, the example is telling us to sketch the direction field for the differential equation y prime, which equals to x squared plus y squared minus 1. Once we have done that, we are tasked with using the direction field to sketch the solution curve that passes through the origin at 0, 0. First, we need to find the slope at several points. Since y prime equals to x squared plus y squared minus 1, all we need to do is plug in the value of x and y for each point we want to test. Basically, at point -2, 0, substituting x, which equals to -2, and y, which equals to 0, gives us 3, which means that we get a steep upward tilt. Now at origin 0, 0, we get -1, which means that it tilts downwards. Now at 1, 0, we get 0, which means we get a perfectly flat line. As we continue to do this over each individual point, we slowly start to get an idea of what the slope field will look like. Once we have substituted all points, from there, all we have to do is draw short line segments with those on the coordinate planes. Now we want to draw the slope field. Remember, each segment represents the slope of the solution curve at that location. If we draw more and more of these, we can start to slowly see the pattern of the field. The pattern will start to look like a flow of wind, showing the direction in which the solution moves. Now, we want to sketch the solution curve in. We start at the origin 0, 0 because that's the point the problem gave us. At the origin, the slope is -1, so we begin by drawing the line moving downwards to the right, matching the slope. As we move slightly away from the origin, we look at the nearby line segments and make sure our curve always stays tangent, meaning that it always follows the same direction as these little lines. To finish it, we can return to the origin and extend the curve to the left side as well, keeping it tangent to the nearby slopes. Now, some of you might still be confused about this, so what does this picture actually mean? Each tiny line in the slope field shows how the slope changes depending on where we are. When we connect those lines smoothly, we get a curve that's our solution. This helps us see how the differential equation behaves, even if we don't know the exact equation for the curve. If we were to start at a different point, for instance 0, 1 instead of 0, 0, we would get a different curve, but it would still follow the same flow of slopes because all the curves are shaped by the same field. Basically, slope fields allows us to see what's happening. They show us if a solution is going up or if it's going down or if it's staying flat just by looking at the direction and steepness of those little lines.